Myself Dinesh, working as Assistant Professor, Department of Physics. Dear students, in this video lecture, I am going to explain the topic astrophysics. Here, astrophysics is a branch of astronomy. It is the study of the universe, the formation of galaxies, and the properties of stars. The study of what the heavenly bodies are made of, their temperature and pressure, their atmospheres, their radiation and brightness, and so on, are the area of interest in astrophysics. Here, before going to the properties of stars, like temperature, pressure, and so many things, first we have to understand the stellar distances. What are the units taken to measure the stellar distances? Here, first one is astronomical unit. It is denoted as AU. The astronomical unit means it is the distance between the earth and sun is called astronomical unit. Here, one astronomical unit is equal to 1.5 into 10 to the power of 8 kilometer. This is 1.5 into 10 to the power of plus 8 kilometer. This is astronomical unit. Here, what do you mean by light year? Light year. ಇದನ್ನು ನಾವು ಕನ್ನಡದಲ್ಲಿ ಜ್ಯೋತಿರ್ವರ್ಷ ಅಂತ ಕರಿತೀವಿ. Here, light year means it is the distance covered by the light in 1 year is called 1 light year. It is the average distance covered by the light in 1 year. Here, 1 light year is calculated as follows. Here, the velocity of light should be 2.997 into 10 to the power of 8 into 365 days into 60 minutes, 60 seconds into 24 hours, which is equal to, on calculation of all these things, we get 9.451 into 10 to the power of 15 meter. Hence, 1 light year is equal to 9.451 into 10 to the power of 12 kilometer. Here, 1 light year is equal to 63,300 astronomical unit. Here, 1 light year, it is in kilometer. When it is converted into astronomical unit, the value becomes 1 light year is equal to 63,300 astronomical unit. Let us see stellar parallax. What do you mean by stellar parallax and how it is calculated? See here, for this one, see the diagram here. It is stellar parallax means here the distance of star from the earth is measured in terms of an effect known as parallax. That is said to be parallax. Now, what do you mean by stellar parallax? Stellar parallax is nothing but it is a measure of stars distance from the earth surface. Here, shown in figure, E dash are the positions of earth around the sun, because earth revolves around the sun in an orbit, respective orbit. Here, sun located in the time interval of 6 months. Here, E dash is the baseline is star alpha. Here, star alpha, let's suppose it is alpha, is photographed from the position E of earth against background faint of stars. Again, alpha is photographed from the position E dash of star after 6 months. Here, one half of the angle subtended between these two observations gives annular parallax or stellar parallax of star. Here from figure, sin p equals 1 astronomical unit upon d. Here sin p, it is a subtended angle p. Here from the triangle, right angle triangle SE alpha, you can define sin p. Here sin p means opposite is, this is 1 astronomical unit, hypotenuse is d, distance between the star and surface of the earth at the position E. Therefore sin p equals 1 astronomical unit upon d. Even though for very nearer stars p is less than 1 second of an arc, therefore sin p equals p. The sin term is ignored here. Therefore the p, subtended angle p in terms of radian, is equal to 1 astronomical unit upon d. Let it be equation 1. Here d is the distance of the star from the surface of the earth at the position E. Here now convert 1 radian into seconds. For conversion, 1 radian is equal to 180 degree by pi. That means 57.295 degree. When 180 is divided by pi, its value is 2,06,265 seconds of an arc. Therefore, subtended angle P radian is equal to P second upon 2,06,265. Here you can substitute this value in equation 1. Equation 1 for P radian, it becomes P second upon 2,06,265 equals 1 astronomical unit upon D. Therefore D equals 2,06,265 astronomical unit upon P second. Just you cross multiply above equation, we get this value. Let us consider 2,06,265 astronomical unit as unit of distances. Then in this unit, d equals 1 by p second. If the parallax of 1 second, that means p second is equal to 1. If p second equals 1, then d is equal to unity. Therefore d becomes 2,06,265 astronomical unit. Therefore when it is converted into kilometer, just 2,06,265 is multiplied with 1 astronomical unit distance. 1 astronomical unit is 1.5 10 to plus 8 kilometer. Then it becomes 3.09 into 10 to 13 kilometer. This is equal to 3 into 10 to 16 meter. This unit is called 1 per second. 1 per second. Here 1 per second means it is defined as, it is the distance at which the radius of the Earth's orbit subtended an angle of 1 second of an arc. Here 1 per second is defined as, it is the distance at which the radius of the Earth's orbit, here radius of the Earth orbit is 1 astronomical unit, it subtends an angle of 1 second of an arc. Therefore 1 per second equals 2,06,265 astronomical unit. This is equal to 3 into 10 raised to 16 meter. But 3 into 10 raised to 16 meter is nearly equal to 3.26 light years, because 3.26 into the speed of light 3 into 10 raised to 8 into 365 days 24 hour into 60 minutes into 60 seconds, we get 3 into 10 raised to 16 meter. Therefore 1 per second, here the 1 per second 1 pc is equal to 3.26 light year. This is 1 per second value in terms of light year. Let us see the physical properties of stars. Here the important properties of stars are brightness, luminosity, temperature, size, density and the mass. These are all the physical properties of stars. Let us study one by one. Here the first property of the star is brightness. That means magnitude scale. Here the brightness of star differ from one another. Some stars appear bright and some very faint. The magnitude scale has been developed on the basis of measurement of brightness of star. Hence, the brightness of a star is measured on a scale called magnitude scale. ಇಲ್ಲಿ ಬ್ರೈಟ್ನೆಸ್ ಯಾವುದೇ ಒಂದು ನಕ್ಷತ್ರದ ಬ್ರೈಟ್ನೆಸ್ಸನ್ನು ನಾವು ಮೆಜರ್ ಮಾಡಬೇಕಾದ್ರೆ ಅದನ್ನ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಸ್ಕೇಲಲ್ಲೇ ಮೆಜರ್ ಮಾಡ್ತೀವಿ. ಎಲ್ಲ ನಕ್ಷತ್ರಗಳ ಬ್ರೈಟ್ನೆಸ್ಸು ಸೇಮ್ ಇರೋದಿಲ್ಲ. ಒಂದೊಂದು ನಕ್ಷತ್ರಗಳು ಒಂದೊಂದು ಬ್ರೈಟ್ನೆಸ್ ಮತ್ತು ಲ್ಯೂಮಿನಾಸಿಟಿಯನ್ನು ಹೊಂದಿರ್ತವೆ, ಒಂದೊಂದು ಟೆಂಪ್ರೇಚರ್ನ ಹೊಂದಿರ್ತಾವೆ. ಟೆಂಪ್ರೇಚರ್ ಬೇರೆ ಬೇರೆ ಇರ್ತವೆ. ಒಂದೊಂದು ಸ್ಟಾರ್ಗೆ ಒಂದೊಂದು ಟೆಂಪ್ರೇಚರ್ ಇರ್ತದೆ, ಹಾಗಾಗಿ ಬ್ರೈಟ್ನೆಸ್ಸು ಕೂಡ ಡಿಫ್ರೆಂಟ್ ಇರ್ತದೆ. Here the magnitude of a star is the measure of its brightness when observed from the earth. ಇಲ್ಲಿ ಬ್ರೈಟ್ನೆಸ್ ಆಫ್ ದಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಎ ಸ್ಟಾರ್ ಅನ್ನೋದು ಟೋಟಲ್ ಆಗಿ ಆ ನಕ್ಷತ್ರದ ಬ್ರೈಟ್ನೆಸ್ಸನ್ನು ಭೂಮಿ ಮೇಲೆ ನಿಂತ್ಕೊಂಡು ನಾವು ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀವಿ ಅದನ್ನ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಸ್ಕೇಲ್ ಅಂತ ಕರಿತೀವಿ. ದಟ್ ಈಸ್ ದಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ಎ ಸ್ಟಾರ್ ಅಂತ ಕರಿತೀವಿ. ಇಲ್ಲಿ ಗ್ರೀಕ್ ಅಸ್ಟ್ರಾನಮರ್ ಹಿಪಾರ್ಕಸ್ divided the naked eye stars into 6 magnitude classes. ಇಲ್ಲಿ ಗ್ರೀಕ್ ಅಸ್ಟ್ರಾನಮರ್ ಹಿಪಾರ್ಕಸ್ ಅನ್ನೋನು ಈ ನಾವು ಬರೀ ಕಣ್ಣಿನಿಂದ ನಕ್ಷತ್ರಗಳ ಗುಂಪನ್ನು 6 ಭಾಗವನ್ನು ಮಾಡ್ಬೋದು ಅಂತ ಅವನು ತೋರಿಸ್ಕೊಡ್ತಾನೆ. ಅಕಾರ್ಡಿಂಗ್ ಟು ಹಿಮ್ ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಬೇಸ್ಡ್ ಆನ್ apparent brightness of a star is called apparent magnitude. It is denoted as small letter m. The actual brightness of star is called absolute magnitude m. Absolute magnitude m. Here the apparent magnitude means, what do you mean by apparent magnitude? It is denoted as m, small letter m. Let us see what is apparent magnitude. Here the stars which appears to naked eye in the night sky have been divided into 6 groups in the descending order of brightness. That is, first group of stars are brightest and second group of stars are little fainter and so on. Last one, sixth group of stars are faintest visible stars. Sixth group of stars are faintest visible stars. It was found from the stellar photometry experiments that first group of stars are 100 times brighter than sixth group of stars. That is, brightness ratio is 100:1. It was also found that equal ratio of brightness would give an equal differences in magnitude. That means the brightness ratio is B1 by B2 equals 100. Therefore, it also written as the brightness ratio for two stars B1 by B2 into next two stars B2 by B3 into B3 by B4 into B4 by B5 into B5 by B6, which is equal to B1 by B6. First magnitude to sixth magnitude. This is equal to the ratio 100:1. That means 100. But B1 by B2 equals B2 by B3 is equal to B3 by B4 is equal to B4 by B5 is equal to B5 by B6, which is equal to, let's suppose it is X. Say it is X. Here, according to the above statement, B1 by B6 equals x to the power of 5. Here there are 5 ratios are there. Therefore, x to the power of 5 is equal to, between 1 to 6, x to the power of 5 equals 100. Therefore, b1 by b6 equals fifth root of 100. Here fifth root of 100 is 2.52 or 2.512. Before, the ratio of brightness of two stars whose apparent magnitude differ by unity is equal to 2.52. The ratio of brightness of two stars whose apparent magnitude differ by unity, which is equal to 2.52. Let Bm and Bn be the brightness of two stars having magnitude m and n respectively. If, let's suppose, n is greater than m, then the ratio of those two stars m and n written as Bm by Bn equals 2.512 to the power n minus m. Taking log on both sides of the above equation, we get log of Bm by Bn is equal to n minus m into log of 2.512. Here log of this one is RHS is n minus m into log of 2.512. Here log of Bm by Bn is equal to n minus m into 0.4. Here log of 2.52 is 0.4. Here when 0.4 comes towards LHS of the equation in the denominator, then on simplification of above equation we get n minus m equals 2.5 into log of Bm by Bn. Here this equation, this final equation shows that higher the magnitude of star, less is its brightness. Higher the magnitude, lesser the brightness, or smaller the magnitude, higher the brightness. This is the apparent magnitude. Let us see the absolute magnitude. Here absolute magnitude is the measure of actual or intrinsic brightness of the star. It is the measurement of brightness of star when it is placed at a distance of 10 parseconds. That means 32.6 light years. Therefore, absolute magnitude is defined as it is apparent magnitude would be if it were placed at a distance of 10 parsecond from the earth. The apparent magnitude if it were placed at a distance of 10 parsecond from the earth. ಅರ್ತಿಂದ 10 ಪಾರ್ಸೆಕೆಂಡ್ ದೂರದಲ್ಲಿರ್ತಕ್ಕಂಥ ನಕ್ಷತ್ರಗಳನ್ನ ನಾವೇನು ಬ್ರೈಟ್ನೆಸ್ಸನ್ನು ಮೆಜರ್ ಮಾಡ್ತೀವಿ ಅದನ್ನ ಅಬ್ಸಲ್ಯೂಟ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಮೆಥಡ್ ಅಂತ ಕರಿತೀವಿ. ಲೆಟ್ ಎಮ್ ಬಿ ದ apparent magnitude of a star whose brightness is Bm and the distance is d. Let's suppose another star whose apparent magnitude is m, capital letter M, whose brightness is Bm and the distance of the star from the surface of the earth is capital D. Therefore, we know that m minus m is equal to 2.5 into log of Bm by capital Bm. It is already derived in the last slide. Brightness of any object is inversely proportional to square of its distance. That means all the stars obeys inverse square law. Therefore, according to inverse square law, Bm, the brightness of m star, which is inversely proportional to square of the distance, that means 1 by d square, and brightness of second star is directly proportional to 1 by d square, that means Bm proportional to 1 upon d square. Here Bm equals, when it is equal to, proportionality constant is equal to, then it becomes constant upon d square. Here it is also Bm equals constant upon capital D square. Here constant is the proportionality constant. It has some values here. On dividing these two, Bm by Bm equals D square by D square. Here Bm upon Bm equals Bm upon B capital M is equal to capital D square by small d square. Therefore, we can substitute Bm by Bm value in this equation, above equation. We get M minus M equals 2.5 log of, for Bm by Bm value is d by d whole square. Here M minus M equals 2.5 log of d by d, because 2 into 2.5, we can multiply this one, we get 5, that is 5 of log d minus log d. Here log of d by d means log of m by n means log m minus log n. In the same way, log d minus log d. But capital D is the standard distance for absolute magnitude. D equals 10 parsecond. According to the definition of absolute magnitude, the distance d equals 10 parsecond. We can substitute in this equation for value d. We get m minus m equals 5 into log 10 minus log d. This is equal to 5 into log 1 minus 5 into 1 minus log d, or m minus m equals 5 minus 5 log d, or it is also written in the form of m minus capital M equals 5 log d minus 5. This is the relation between the apparent magnitude m and the absolute magnitude capital M and the distance d of the star in parsecond. This equation is called distance modulus relationship. This equation gives the distance modulus relationship. The quantity m minus capital M depends only on the distance d and is called the distance magnitude. If m minus capital M is known, the actual distance of the stars can be calculated. Let us see the bolometric magnitude. What do you mean by bolometric magnitude? Here, stellar magnitudes measured in the above mentioned procedure covers only visible region of electromagnetic radiation, because our eye is particularly sensitive to green and yellow light only. But a star radiates all electromagnetic radiation from radio waves to gamma rays. Therefore, the stellar magnitudes based on radiations measured over the entire range of electromagnetic spectrum is called bolometric magnitude. Here M bolomagnitude for apparent bolometric magnitude and capital M for a absolute bolometric magnitude. If capital M that means absolute bolometric magnitude with the bolometric magnitude of star of brightness B, and M absolute bolometric with the bolometric magnitude of sun of brightness B, brightness of sun, then M bolometric magnitude star minus M bolometric magnitude for sun is equal to 2.5 log of B, that means brightness of the sun to the brightness of the star. This is the bolometric magnitude equation, particularly for sun and other star. Let us see the luminosity of stars. Here, the luminosity of a star is the measure of total amount of energy. That is the measure of total amount of energy that is radiated from its surface in 1 second in all directions, in all possible directions. Luminosity of star is expressed in terms of luminosity of sun and measured by absolute bolometric magnitude of the star. If M bolometric and L are absolute bolometric magnitude and luminosity of star respectively, and M sun bolometric magnitude and L star circle indicates luminosity of the sun, then it becomes M bolometric minus M bolometric for sun is equal to 2.5 log of the luminosity of sun to the luminosity of star. Here the bolometric of Sun is nearly plus 4.72 and luminosity of Sun is 3.84 into 10 to the power of 26 joules per second. If T is the effective temperature of the star and R be the radius, then total luminosity of a star is given by the formula L equals 4 pi r square into sigma T to the power of 4, where sigma is the Stephens-Boltzmann constant whose value is 5.67 into 10 to the power of minus 8 watt per meter square per Kelvin raised to 4. This is Stephens-Boltzmann constant. It also expressed in solar unit as L by L naught equals, here L, R and T are corresponding to the stars. These are the properties of stars and data of the stars. L naught, R naught, T naught are the data of the sun. These are values are corresponding to the sun. Therefore, luminosity ratio star to sun is L by L naught equals R by R naught square whole square into T by T naught whole to the power of 4. This is the expression luminosity relation in terms of solar unit. Here in this chart we can recognize or identify the apparent magnitude and absolute magnitudes of the stars, different stars. Here for sun, apparent magnitude should be minus 26.5 and absolute magnitude is plus 4.8. For Sirius star, it is apparent magnitude is minus 1.46, absolute magnitude is plus 1.5. Canopus, that means Agastya, its apparent magnitude is minus 0.72, and Alpha Centauri, that means in terms of local language Kindarapada, its apparent magnitude is minus 0.27. Arcturus or Swati, its apparent magnitude is minus 0.04. Vega or Abhijit, its absolute magnitude is plus 0.03. These are the apparent and absolute magnitudes of different stars which we can see. Yes, ಈ ಸಿರೀಸ್ ಅನ್ನೋ ನಕ್ಷತ್ರ ನಮಗೆ ಬರೀ ಕಣ್ಣಲ್ಲಿ ಕಾಣಿಸ್ತಕ್ಕಂಥದ್ದು. ನಮಗೆ ಉತ್ತರ ಮತ್ತು ದಕ್ಷಿಣ ದಿಕ್ಕಿನಲ್ಲಿ ಆಪೋಸಿಟ್ ಸಿರೀಸ್ ಎ ಮತ್ತು ಸಿರೀಸ್ ಬಿ ಅನ್ನೋದು ಭಾಳ ಬ್ರೈಟಾಗಿ ಕಾಣಿಸ್ತಕ್ಕಂಥದ್ದು. ಸೂರ್ಯ ಮುಳುಗಿದ ತಕ್ಷಣ ನಮಗೆ ಆಕಾಶದಲ್ಲಿ ನಾವು ಕಣ್ಣಾಯಿಸಿದಾಗ ಕಾಣ್ತಕ್ಕಂಥ ನಕ್ಷತ್ರ ಸಿರೀಸ್ ಅನ್ನೋದು ಅದರ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಇಷ್ಟಿರ್ತದೆ. This is about the magnitude scale and apparent magnitude and absolute magnitude and luminosity of stars we have studied here. In the next video we can discuss about the stellar temperature and birth of star, death of stars and other things. Okay, thank you.